Good evening, everyone present
Good
today
evening.
with us.
Good evening, sir.
Uh,
Good evening, everyone.
Good evening.
it is my privilege to welcome you all in this 10th talk of this year. And on behalf of National Astronomy Network of IAPT, I welcome you all in this evening. And you know that NASNI is uh, encouraging new stargazers and enthusiasts, and we engage many activities in astronomy and sky watching among students, educators, and general public. And in this NASNI, we have one of the most engaging activities, that is a series of virtual talks, and which organized on the Zoom platform. These sessions have successfully brought people from across the nation, creating opportunities for knowledge sharing and interaction in the field of astronomy. And in this series today, we have a very prominent speaker with us, Dr. Bharat Adur, and we also have with us uh, Dr. Mangesh Sutar from Bombay. And now I will request to Dr. Sutar to introduce our speaker, and please invite him for this talk. Dr.
Thank you.
Mangesh.
Thank you, sir. Thanks a lot. And welcome everyone to NASI Talk 20th May 2026. As Hemant sir said, this is the 10th talk of this year. And today we have our great speaker, Dr. Bharat Adur, senior scientist from Nehru Planetarium, Mumbai. He is also director for Akash Ganga Center for Astronomy, Badlapur. As I said, senior scientist, he has served as a senior scientist at Nehru Planetarium, Mumbai for almost 33 years, contributing significantly to its development, involvement in installing vertical kiloSAT 12-inch solar telescope at the planetarium terrace highlights the commitment for advancing solar observations. Bharat sir has been actively involved in creation of various exhibits, translate presentation, mini planetariums, AV shows, 19 major planetarium shows and film titled Planetarium in Planetarium shows, dedication to educational outreach and popularization. Another thing what I can tell about Bharat sir is about his experience in observing 19 total solar eclipse, organizing camps for comets, meteor observations, constructing numbers of telescopes and accessories. He has immensely contributed to scholarly contribution to event of numerous articles published in scientific journals and magazines for last almost 20 plus of years. As he has the PhD in astrophysics focused primarily on star clusters and recognition as a fellow of Royal Astronomical Society, London. That was his major achievement. Then past 20 years, he has led Akash Ganga uh, Center for Astronomy as its director, fostering research in primarily in meteor physics, meteorite exploration, recovery, and then analysis related to radiochemistry. And recently has adopted a new technology also about exploration of meteorites. His research papers have been published into the scientific journals in India as well as international journals, further demonstrates his expertise and impact on the field. He has already been collaborated with observatory in France, United Kingdom, USA, and works with 2.2-meter telescope and Indian Institute of Astrophysics, Kavlut in 1990, highlights his global engagement in astronomical research. So today's his talk is on techniques for the detections of meteorites and impact craters. With that, I would like to welcome our eminent speaker, Dr. Bharat Adur, for today's NASNI talk. Welcome, sir. Welcome to the talk.
Thank you. Thank you very much, Mangesh. And thank you, Professor Hemant. It's a pleasure for me to give this talk One of the reasons why I have been asked to take a topic of impact craters, and the reason why I'm going to talk about is the impact crater itself is a physics. How there is potential energy and kinetic energy used for understanding the impact physics. I remember in my childhood days, we used to use marbles and the place was a small place, but in that smaller marbles were put, and then uh, one had to choose that particular marble and then hit that with the another marble, and that is how we were able to play marbles. And one of the very interesting fact is a marble, if it is dropped just in the sand or even in the soil, it creates some kind of a crater. And that crater is normally dependent upon the diameter of the steel ball or even the marble glass ball, and you can see the impact. But if the soil is slightly wet, then you can see actually how the impact has happened. This is one simple example which I can tell you to understand impact craters. Impact craters is basically not a very difficult proposition. All what one requires is a flat soil, and on that, uh, at our observatory, we have weighing balls, which are used by gyms for lifting and finding out. They are around 5 to 7 kilos, and then you drop it from different heights, and by that you are able to create a crater in the soil itself. So one of the exercises to understand impact craters, the steel ball on a wet soil is an excellent example, and one can try doing it with different. One can throw it at an angle and see how the craters are formed. And what happens actually in crater formation is just not the potential energy, but it also takes kinetic energy. So this is how the meteors, which are coming from the sky at a very high speed, when they come down, firstly, because of its composition, they shatter up and then they form smaller, uh, kind of small rocks, and they try to come down. But the Earth's atmosphere acts as a friction, or rather it stops that from coming. So in turn, these small meteorites get burnt in the atmosphere itself, and they don't reach the ground. However, the larger ones are the ones which actually make impact onto the ground. And then today I'm going to take this topic of laser impact crater physics. The idea of doing impact crater physics is normally one thinks how it can be done. But as I told earlier, that the impact is basically depending on two factors. One is the potential energy, and the another is a kinetic energy. Now, I will tell you further on how these craters are formed not only on Earth, but it has happened on Moon. It has happened on every planet, and that I am going to show you different examples, and thereby how the physics of impact craters takes place. We have in India, in Maharashtra, we have a crater called Lonar Crater. Normally, it is considered to be not a circular, but a slightly elliptical crater, because at one end you find the entry point, which is at an angle, and then you find the lake. Now, we are also studying Lonar Lake, but today I am going to specifically emphasize on Lonar Lake for two reasons. This is the only meteorite which has hit the earth, or rather in Lonar, in the basalt part of it, which is a very strong rock. And in that rock, it has punched in a crater at least 600 meters down. And this 600 meters down, it has gone and has created a lake. We have been studying this for last 20 years, and now I would like to share. Now there is a very great necessity of telling about Lonar, because that lake water has now suddenly come up, and the region around that, which means there was many temples around the lake, are now flooded, and there is a likelihood that it might destroy this crater. So, my earnest request to all of us who are listening to this talk is to save Lonar Lake from such disaster. And that is how we are conducting a program on June 30th as an asteroid day, and we are going to highlight on Save Lonar, because that is the only crater which is a complete established meteor crater in the world. And it is the third largest crater in basalt in the world. So it has a very big significance. It is geoscience heritage site. Hence, my request to all of our members is to look at these craters, and also craters in India, which normally we talk about two or three more, one in Ramgarh and one more, and then the recent one which we have also been doing field expedition in Luna in Gujarat near Kutch. So these are the craters so far known in India. But for your information, I would like to add, we have made a catalog of meteorites which have fallen in India since 1700. And many of these meteorites have been in Calcutta at GSI, Geological Survey of India. They are kept in that premises. Another thing which I want to share, that in our catalog of 162 meteorites which have fallen in India from 1700 onwards, we would like to upgrade our observation, and there again I seek all of your support to do this kind of work. So I request Mangesh, can we start with the slides?
Yeah.
Yes, sir. It is visible, sir. Second
Is it
slide.
visible, sir?
Yeah.
Yes, sir.
Can it be? Can you
Yeah.
expand it?
Impact crater vocabulary.
Impact Crater Lab. It's full screen, sir.
Okay.
Impact Crater Lab.
Okay.
Can you see, sir, this slide?
Yeah, I can.
Okay.
Heman, sir, you are able to see it full screen, right?
Yes,
No,
yes.
I'm not able to see full.
It is not in full screen. Now we can see.
Okay. No, I'm not able to see the screen. But still I will continue on my topic.
It is impact. It is impact crater lab, sir.
Uh-huh. Uh, Mr. Sutar, can you expand it?
That's the maximum, sir. It's a full screen.
Okay.
From my end, it is full screen.
But
Your
yeah,
laptop or a mobile?
I'm on laptop. So should I say share?
No, no, not required. You don't require to do anything. You just have you are able to see the screen or not. You are able.
No, I'm not able to see the screen. So I'm asking you for that.
No, no, no. You should stay. Click
Earlier, I was able to see.
on top. There is something called My Screen. You might be seeing meeting. You must see. Click on My Screen. When you say My Screen, then you will able to see the presentation on top. I think you have clicked on meeting. What is that you are seeing on screen? Are you able?
I'm only seeing the participant, and I have cut my video. That is all. But below that,
You're not seeing the presentation view. You should click
yeah,
on screen, my screen.
yeah,
My screen, yeah, Mangesh Sutar
yeah,
screen.
Yeah,
yeah, yeah, yeah. So I am coming directly to this topic of Impact Crater Lab.
Lab.
correct.
One
Yeah.
can make Impact Crater Lab. It is very interesting to do this even in a lab, or not necessarily. One can do it even in their house. One of the reasons why I'm showing you these part of it is how to do this kind of a experiment, and all that what one needs in a house is uh, uh, wheat flour, which you can spread it on a paper or maybe on a uh, some sheet. You can spread out the wheat powder or wheat flour on the and then you can sprinkle it with little cinnamon or dalchini to make it a thin layer onto the wheat flour, which is spread on a small small kind of thing, and decide what type of objects you want to see as a meteor crater. This is purely a lab experiment. You can do it even in the house. And what you can do is either you can take marbles, or you can take steel marbles or the iron marbles, and put them at different heights and drop it down. And when you drop it from there, you will get to know what is the velocity at which it is coming, which is essentially mass into gravity into the height. So it is essentially MGH, and the floor will show you a crater formation. You can even measure a diameter, depth, length, all this you can record it. Similarly, you can raise the height of the impactor. We call this as an impactor. Either it is a marble or a steel ball. In playing marbles, you get some kind of a heavy one, which is called as a big marble to hit a smaller marbles. So that also you can use, and essentially you can see, you can measure each measurement by looking at the floor and the formation of the crater. You can even slightly tilt from 90 degrees drop to maybe say 50, 60 at different angles and see how the crater is formed. So this can be done from 60 centimeters, 90 centimeters, and 2 meters. Unfortunately, we do not have measures in India on our rocks or on our place. I do not know why we are not training our young friends into doing this kind of a lab where you drop a marble or a steel marble onto the floor, and you can see this spread, and you can do it more than 3-4 times and find the average measurement which you can do it within the house. This is one exercise which I am trying to tell you, and what physics you are going to learn out of this is very interesting. And can we go to the next slide? Now, in the impact crater, there is a vocabulary. The floor here is known as the soil on which the impact is going to make, and it will be made as a bowl. Now, this bowl making is called as a floor. Then there is where you drop, or where the meteorite meteor drops, it creates some kind of a mountains or hill-like structure. And that happens due to the increase and decrease of pressure during the impact. And this central uplift is primarily because where it has impacted, it has thrown the soil from below up, and there you get a small hillock kind of a structure. And the area around the crater is known as a wall. Now, why are we talking about impact craters? One of the reasons of talking about impact crater is we are going to have the Chandrayaan-4 going to go to the crater, and probably the effort is to go to the far side of the moon and look for details. And the most important part in that is to determine impact craters on the far side. And the mission which has been done by the recent Themis, and they have got some pictures. The Chinese have gone there and they have found, and they have seen these features: floor, central uplift, wall, raised rim, where all the material from the ground is thrown up and it forms a kind of a raised rim along, and those are called as a wall. And beyond that, beyond the rim, you do find a lot of this soil along with the meteoric impact part of it into the other regions, and whatever has gone there, it is coming out of the crater itself and falls along, and that is called as a ejecta. The another important thing that is seen is the rays in the crater itself, but some craters you are not able to see because either there is a water spread around to great distances, and it is not necessary that only one meteor will hit and throw all this. The normal process of a meteor, when it is coming towards the ground, it can break in several pieces. I will show later how things have happened in the craters, and in some there are complex craters features. So this is one reason that we should understand impact craters, very important, and one can do a whole physics out of this and find out what is the way the craters are formed. Here in India, we talk mainly about 3 to 4 craters. And Indian continent is spread over a very large area. Now here you are able to see, this is on the surface of moon, where you can see the floor, you can see the ejecta, you can see the rim, you can see the wall. Now these walls are very long, very tall, They extend up to 60 meters from the lake to the top, and along the top you will find uh, what we call it as a rim. Even if you go down to Lonar, you are able to see all these features. And also, if there were secondary meteors, they will also show you a crater formation, which I think I will show you later. But these are the parts of the crater which we look for in an impact crater. Now, one more idea we want to add with this is how it is going to be studied. And for studying, here we are looking at the volume of the crater being thrown out. The map, the soil and all. I have given some equations. You don't have to be worried about it because these are functional relations with the mass, with the velocity, and also with the pressure. The pressure is very heavy because you are having a large mass, and I will show you later what different mass will happen and what will happen. It has even one of the craters which has formed. It has formed in the seabed in Mexico, called as Chicxulub, and their volumes are looked at by doing this. Please understand one thing: for understanding impact craters, one needs to look at one's own soil. And unfortunately, we here do not have any measure what would be the impact parameters on our soil. Fortunately, in India, we have different soil patterns spread across the whole country. And most important among that, one should use at our end at Akash Ganga, we have a small setup where we check even the soil which is there around the premises. We use that and try to find these 7 8 components to understand how the cratering volume can happen. And for that, the simplest impactor type, the one impactor type is nothing but actually here we consider impactor type is the aluminum, plastic, steel, and then different kinds of chondrites. And those measures we find by doing the density test. Now, these are all can be done in any small labs. It is not necessary you should have a very big lab and so on. But after the impact has happened, it is necessary to check the vocabulary that I showed you earlier. We got to really know. Earlier, the and one of our mentors had actually drawn the plots, and then in the plots we were able to know where the tektites had fallen, where the glassy material had fallen, and where only the soil was thrown out. All these are, one can study that. Now here, I want to show you one. There are good number of equations, and fortunately, these equations today you have softwares wherein you can try with different materials and find out the soil test. What we have done, we have taken soil from Chowpatty, Bombay, by the seaside, and we had done some experiment of if the meteorite were to fall in the sand, how much diameter it will make. And normally it is nearly 1.3 to 1.8 times the size of the ball which you are going to drop. So that is how we are able to find the shapes for simple craters and for more advanced kind of thing. But this you can even calculate with the softwares. How much will be the crater size and what all types are there. And in the impact craters, you will definitely be able to find the shape of it. Here I mean the shape of the crater. That is, it will have hills, it will have a rim, and then it will have a center where the impact has happened, and there you will see a small bulge which we call as a hill inside the crater. And if there is no soil, but if there is water, you will not be able to look for that hill. So this is one thing which you can actually calculate, and there are softwares available both in Windows and in on Python. One can do these calculations and try to simulate what has fallen. So it is not just a crater happening and that's the end of it. No, you have a lot of physics to learn from this. You can get to know the what is the excavation. Now what happens when a meteor falls? A lot of soil is thrown out, and the soil which is thrown out is roughly between 1.8 kilometers to even 20-25 kilometers. And then there are references for explosive craters. Now, explosive craters are below the soil of any planet. If there is a volcano and if that bursts up, then it might make that crater a little different. There are different types of craters which are formed all over the planets, whether it is Mercury or whether it is Venus or whether it is our own moon. There are craters, and such craters are found even on Earth. I have some examples to show you how even on Earth the craters are formed. And beyond that, on Earth also, one of them is around 250 kilometers across. It's a very large crater, but it is in South Africa. It is called as Rutherford crater, and this crater is fairly old. But you can understand one thing, that crater formation on Earth or anywhere else or any other planets will have a more or less a similar feature. So what we learned from Earth Impact Labs, here you can expand it to craters on Earth also. And here I am showing you Chicxulub in Yucatan Peninsula in Mexico. And the year is expected to be 65 million years back. And here the diameter, it is below the sea, is around 170 kilometers. And the expectation is the dinosaurs were killed because of this meteorite, which hit the ground and had created several layers of, even in the atmosphere, it went more than 10 kilometers above the from the impact point up into the atmosphere. Thereby, the sunlight was blocked, and the animals, that dinosaurs, could not survive because there was no sunshine for many, many months. And these animals did not get enough, so they were more or less extinguished from the surface of Earth. But here next to Mumbai, there is a Shiva crater. Now, people may have doubts whether it is a meteoric crater or what, but this crater is fairly close to Mumbai, and it is in the sea around 200 kilometers, less than 200 kilometers. You have these peak fusion regions where one is able to get the oil out of it. But the diameter of this is around 5 to 600 kilometers. So this Shiva crater had already created, Bombay probably must have the lava which has come from these craters, which has created a volcanic activity along the west coast, could have been possible because of such a meteoric hit and the volcano must have been activated. And in this region, you do find oil pits. How do they know that it is from the oil pits? They have bored in the seabed to a depth of around more than 3 kilometers or 4 kilometers, and there are huge when they bore the seabeds, they go fairly low, and thereby they get the soil and the rock samples, and along that they are able to get one particular line which they call it as KT line, which tells that it could be a meteoric crater. So this is a speculative part, and I request the people who are listening to this. It is one of the fundamental work which one can take up in Mumbai also, and the data can be available with ONGC or any other uh, the bore which has been done in these high what they call it as high peaks is also there. So you can actually go to Dehradun. They have a petrographic details of this, and they have these soils available there. So one can even use these soils to look for the KT patterns. Now KT pattern is nothing different, but it tells you that this event must have been somewhere closer to what crater which we saw earlier in Chicxulub, and this was not very far because our Indian plate at that point was in the sea. It had not moved to the place where it has. So thereby one can see that Shiva crater is the best possible crater which one can take up for studies. Uh, Another way of learning is by using satellite data. Now, unfortunately, when we began our work, getting a GPS was difficult. But later, with the coming of digital watches, there is GPS involved in it. So one can actually see this is Lonar Crater, and this is a satellite image, and there by you can see the rim as well as the lake, and the amount of the ejecta which has been thrown out of the Lonar Crater is such a large area that we were able to get good samples from this crater. Besides, as I told you earlier, that over here you will see another small crater which is called as Ambartale, which is very close to Lonar. But in Ambartale, you do get a depression, and the rock which has been fallen there is being installed in a temple called Zoplela Maruti. That means sleeping Hanuman. But here you can get a lot of material of meteoric origin. In this area, after the rim area, this is area called as ejecta. Now in ejecta, you will see where all it has fallen. It has also created a secondary crater called as Ambartale or Amber Lake, and there were other lakes which were formed by other fragments of the same meteor around. So one can still study Lonar crater for such impact, and you do get samples. One thing I must tell you very honestly is that the samples are still available. So if you go there, what kind of equipment? In fact, I have told Professor Hemant ji that we have made a small booklet what a geologist will require to go to such places. This is a small handbook, and in that handbook, we have shown what all equipment you can take to these and study these craters further. It is not anymore depending only on one place or another place, but you can do these field trips with an experiment of looking for other materials. So what other materials do you get? You get tektites. Now tektites are glassy materials, and there still a lot of work needs to be done. Then you can do work on even the soil of Lonar. I'm talking of the soil below around the lake. And now that part is not possible because it is flooded. And why flooded? Because there is sudden development all along the crater, and thereby our geoscience, we are desperately trying to save this Lonar crater. And it is in India, so one can really go and see the activity over there. Another important thing which I would like to share with you, at Lonar now you have a planetarium which will be inaugurated in the following month, and also a research center. So the studies of Lonar now have reached to such an extent that we need to find out how a craters are formed, how we can study that. I have my talk, I have a lot of more slides to show, but I will try to show you what I have been able to show. The nearest planet of our solar system is Mercury. Even on Mercury was visited by a man-made satellite, and they were also able to see such craters. You can see smaller ones, and again they also have the ejecta fall around. So even in Mercury, even in Venus, all the inner planets, which we call, has these features. Now, why we are trying to look for all this? When Chandrayaan 4 goes to far side of the Mars, we need young people, young students to take initiative in identifying these craters on far side as well as near side towards the south and the north pole of the moon. Now, one of the features which I would like to share with you, within a crater, there is also a smaller crater over here. And then here you have a dent. So the hill was around here, and this dent is not understood. This is for Mars. But now more data is coming by using Curiosity rover, which actually goes on the surface of looking for such craters on the surface of Mars. Here you will see this crater should have been much older, but you will see the rims out here is eroded, completely eroded. Some part of it over here is now giving in, but you are able to see the lava layers coming up, and these are the lava layers below from the surface to the core. These lava layers have come up to the part of the surface. So these are happenings on Mars. And Jupiter, you must have seen, on Jupiter there was a comet collision, Shoemaker-Levy. And here you will see the marks which it had laid over here. You have a red sunspot here, and you find a shadow of one of its satellites, which is Io, I guess, onto the surface of. So these are features which one can see. You can, as I said earlier, that even in crater formation, there are some complex crater formation. Here you will see nearly more than 12 to 18 craters falling in the same line. And here you will find the ejecta not very strong, but it has formed some kind of a line on the surface of Ganymede, which is a satellite of Jupiter. And crater formations are also seen and other planets. Now the newer information is like this. Titan, Saturn's moon, is expected to have not exactly life as on Earth, but there is a speculation there could be life on Earth. But Titan also has craters. It's not that Titan doesn't have craters. It has craters and it needs to be looked at because it also has a small atmosphere around it. So one needs to explore further on Titan. Similarly, on Uranus, Neptune, and Pluto, I have to show you all that because you will see one of the Mimas, Saturn's moon, has such a huge crater. And what I called it a small hill, it's over here. In this, you will see at the center that there is a small uprising which is called as the kill of the crater. So these are the ones which we have for our solar system, and the numbers are not small. Our interaction with meteorite happened in September 2003, that is 2003. We just happened to read in a newspaper that there was a huge fireball which has come to Odisha, and one of the objectives was to look for meteor shower and also see how its effects on the earth. Now this fireball was so strong that it happened in September late in the evening, but in the evening the fireball was making big noise and people actually, even the rickshaw driver from Bhubaneswar to the bus stand, he said to us that he had to run to take cover in some building and he had to run inside the building. So, what happens when a meteor shower happens over any part of the place or country or a state? What one must try to see is what has happened and how to overcome these kind of disasters. This is what I call it as a disaster management of such fireball meteors falling. And one of the pieces of the meteor which fell over this hut, you will see the whole the roof of the hut was completely burnt. So you can well imagine that fireball which had come had such a huge fire input in that it could make a hole through the place, and then wherever it landed, see, it happened in September, so there were rains, and here where we were, we went to see the deepest meteorite which has gone below the ground, and that was around below the soil. However, we were not able to recover that. The one which we are showing here is a little far off place called, we have named it as Balbhadra, but I don't see any further input on that, whether that meteor crater has been saved. But the fireball event, the debris of that fireball has burnt the grass around, and here the meteorite went all the way 30 feet down. So our job was to look for, can we have the earlier slide, sir? Yeah. So we were looking for a sample of the meteorite. So we went to a place called Sutsudia first and later on to Kendrapada. And at Kendrapada, if we go to the slide earlier, I will show you that also. Can we go to the earlier slide? Yeah. The at he had the meteorite was given to the revenue officer in Kendrapada, and the meteorite were around 3 to 4 pieces. And these, out of which one of them we were able to take a photograph from that, and we were not allowed to touch also, but we were allowed to photograph at that point, and so we knew what the Kendrapada was. Kendrapada is further place from this village. This village is another 1,000 kilometers from uh, Kendrapada, where the uh, droppings of the meteorite, we were able to collect it in this hut and outside the hut also. So looking for craters was only possible at a place near Kendrapada, which was called as Kendrapada itself, and it was a small place called Paschim Sunit and Purab Sunit. At both the places, we were able to find the meteorite samples. Another very important thing that I want to share with you is when this fireball came down, it rained meteor rainfall. What happened is the fireball had broken and one piece of it went towards Sutsudia and the other piece uh, it fell on the roofs of the huts as a fire as a rain, but the rains were of meteor drops. So over there also we were able to collect some samples. So can we go back to the earlier two slides, sir? Yeah. So then what we had to do is we had to find how to analyze these meteorites. Now in meteorites, earlier methods were all chemical and it needed a very large amount of samples. One of the gentlemen, an ex-geologist, wanted 10 grams. Now, when you get these samples, they are less than 10 grams. Some of them are only few grams, 4 grams, 5 grams. So we had also got similarly small fragment of it, but we were not being able to analyze it in chemically analyze it. So we had to seek for other part of it. Hence, we had a dialogue with BRC, and BRC gladly helped us in looking for what are meteorite samples to be looked at and in what way you can study meteorites using neutron activation analysis. So this was our first work on a freshly collected meteorite and then to analyze this. Our further work was on how to compare it with different, so thereby we were able to get more samples from abroad and we compared them with the meteor which we picked up from Odisha. So can we go to the next slide, sir? Next slide, sir. No, before that. Yeah. After that, next to this. Yeah. So you can see that meteorites are not something which only happen once. Here you will find the size of the impactors depending from every hour, every day, they are all small ones. So most of them, they burn up in the upper atmosphere, or rather in the atmosphere, and by the time they try to reach, they are all finished off. So only the ones which are large, they come down all the way. And if you see tsunami kind of devastation. Now, meteorites, when they come with such a high speed, somewhere around 7,000 kilometers per second, then you can well imagine the kind of potential kinetic energy that it has will definitely have impact even in the sea, even on the soil, or even on the large hills. But it is very important to track such meteorites in our day-to-day lives. The reason being, we only realize a problem after that disaster has hit us. We should also explore what are the possibilities of such meteorites coming and hitting the earth. So you can expect a tsunami, you can expect a vast devastation. It is just like if a meteorite was to fall in any city, nearly around more than 30 to 40 kilometers can get completely wiped out. So the exercise here is to see how one can look for these meteors and meteorites in the sky, as well as when they fall. Again, when they fall, if they are very large ones, they will make craters on Earth, and they will be of the order of Lonar or bigger than Lonar. And the periods in which it has fallen, that is also there in this chart. And you will see by the mass distinction ones are between 10 kilometers and 100 kilometers. So you can well imagine if a meteor of that size comes and falls on any place, it is going to be a pure devastation. Can we go to the next slide? Yeah, then what is the frequency? Now here the frequency depends from a P, that is vegetable peas, walnuts, grapefruits, basketball, and how long. In P type, it is in it is 10 per hour, and if they are bigger than vegetable peas, they can be 1 per hour. And if it is a grapefruit of about 6 to 8 inch in diameter, it will be about 1 in 10 hours. Like that, if it is a basketball, again it will be 1 in a month. So like that, if you can see, the 10 kilogram ones are happening not immediately, but they happen over millions of years earlier. And such events have happened in the country. In India also, the first observation of a Martian meteorite was seen in Bihar around 1800. Uh, and it was named as, uh, it was very Shergoti. That was the name. It is a small place in Bihar where this Martian meteorite had fallen, and this has become a piece of study for Martian geochemistry. So, my request to you is that we should look for such craters all over the country, and one of our objectives in Asteroid Day is to make people aware of what. And here we do encourage uh, citizen scientists, amateur astronomers, and also school children, college children to participate in this. It is not a one-man mission. It needs a teams of people. I am aware of one of our mentors. They had taken the help of the schools in Gujarat, and they were able to find a lot of meteorite samples. And that happened because the young school children were able to, they were told how to pick up a meteorite, and thereby they were able to collect a big number. So this part of the study is not just confined to physics department or any, it is for anyone to take interest in studying meteorites. Can we go to the next slide, sir? Now this is Lonar Lake. The picture which we had taken was during 2005 and 2011. And in both the cases, it cannot be covered by one observant. You need a good team of 8 to 10 people to see the whole crater. Now, when I said the wall, rimmed wall is this, and the shores which you are seeing at that point, the water was not all the way towards the greenery here that you see. There were small temples, around 12 of them, and they were much above the lake. Now, even those have been submerged. So that's where we are asking that we should now save Lonar, because that's the only scientific or geoscientific material that we have, and it's a must see object for anyone to understand the universe or the universal fall of a large meteorite, what it will do. Now we'll go back to the what expedition. What do you do at Lonar? At Lonar, what you require is a good planning. And planning is here not any other planning, but how you are going to look for samples. Now these are the samples picked up at Lonar and inside the crater and in the ejecta part of it, or the outer of the rimmer, and these are all we have collected from those samples. So I would now go a little further. Next slide, sir. So what are these classifications of meteorites? You have a whole range of meteorites, and they are mainly separated as chondrites and achondrites. And these are further subdivided into smaller groups, whereby you are able to see different andesite chondrites, metachondrites, stony iron meteorites, and here also you will see different sub-particle which you can see here. And here you will see Shagoti, and then another one is Nakatites and Shasgon in Martian meteorites. So even one can get even from the uh, after the impact happens on either Mars or on the moon, some of the matter is thrown off from these satellites, or rather moon as a satellite. It throws and it reaches the earth. So you have meteorites which come even from the surface of moon. So that is also possible. Now here I am showing you how one can start understanding, and this is one part of it. It is not here in India. It is outside in I think it is somewhere in Europe. Iron meteorites, and even in the iron meteorites, this part is essentially burnt part, and the uh, due to the burning and some smaller impacts, here also you see such kind of features. And when you collect that, it is in grams, so many grams, so many. There are some which are more than that. And how do we understand these are meteorites? These are the image which we, the earlier image. Yeah, there are patterns like this, and that happens because of two reasons. One is the pressure and one is the temperature. Thereby, the minerals in them make a certain pattern in the meteorite itself. So these are called windmill structure. So for identifying, you do need to know about such structures. And one of the exercises we do in expedition is to show these images to all the participants and make them understand what are we looking for. And if you are more interested, you can then start looking for bigger and bigger meteorites. I will tell you one of the things which some of our people did find were the coins of that times in the Lonar Lake. So one of our participant was able to pick up coins of Akbar's time in the Lonar Lake near Lonar Crater. So such things are also possible. Now these are called as chondrules. These round ones, they are known as chondrules. And you will see the surface along with them is the material in which these have come and stuck. So chondritic meteorites are essentially having such features of the things. Similarly, if you take similar chondrites and look through a microscope, you do find such kind of mineral structures around it. Can we have the next slide? Yeah, this is tectites. Basically, tectites are glass. Like essentially, it is silica, and these silicas, what they have done, they uh, they make meteorites in the pattern of a fused glass, and these fused glass they form due to temperature and pressure. We call them as gravel side tectites, and these are also very important for any uh, defining any meteorite. You can actually use this for understanding the tectites. I have a small query. Can I continue, sir? Hemanji?
Yes, sir. Another 10 minutes, sir.
Okay. One of the things which I thought I will share with you, this is the recent event around 2 years back near Shirdi. There is a place called as Kopargaon. Now, in that place, the hut in which the house is, a large meteorite came and fell through the roof. So you can see the roof here, and these meteorites came and fell onto the ground, and some of the samples we have collected, and we are studying this meteorite because it's fairly a new meteorite which has fallen in Kopargaon near Shirdi. Another crater or meteorites which have been found in Maharashtra was in Bid. That was last year. Three pieces fell, but of which only two could be collected. And again, a similar kind of fall which has happened of meteorites coming and falling through the uh, steel roof down to the soil, down to the ground. So these meteorites are also of some interest. One more thing now I want to share with you. You can now look for craters. And one of the craters which we took for our studies was in Luna, that is in Kutch. Uh, and the crater is believed to be fairly old, but again, the ages of these need to be looked at. And the how does one look for craters? Now you have got a lot of imagery coming from satellites, and one of the basic interest of looking for craters on the surface of Indian grounds is now what we are aiming at by using not GPS alone. We are looking for now satellite data for different parts of India to look for new craters. We will call new, but the events must have happened long back. So here you have uh, the crater formed in Luna, and this is how we have been there in 2015 and 16. We were able to collect a good amount of samples, and some samples we are still analyzing and trying to use our 20 years old exercise. Now there is the last one which I want to show you is now we have prepared a catalog of meteorites which have fallen in all over the country. Now this I am showing, I have a whole map of India, and we have around 162 meteorite craters formed on the surface of our Indian continent, and also some part of Pakistan, Bangladesh, Burma. We have all that data. But essentially, we are trying to make it as a catalog for meteorites which have fallen in India, and the people who are interested can look for them in their areas or around the areas which we have pointed, and these are essentially taken from International Meteor Society from their catalogs, and then we have put it in Google, and then we are able to show you these many have fallen, and many of them have fallen before uh, earlier 18th century, 19th century. All that we have cataloged for each state of India. So uh, I not want to say anything more. If you would like to have some questions on this, you are open. And thank you very much, Professor Hemant and dear Mangesh, for helping me to show you all the exhibits of my presentation. Thank you very much, and namaskar to all of my participants. Thank you.
Thank you,
Thank you
Bharat
so
sir.
much.
Thank you very much. We are open for question answer sessions. Sorry, Hemant sir, to interrupt you.
Go ahead, sir. Go ahead, please.
Yeah, so we are open for question answer sessions. If anybody has any questions for Bharat sir or related to meteorite impact craters, we are open.
Adur sir, my question regarding the meteorite and meteors is that whenever we see the falling meteors during some special days, then can we assess that how far it is falling from we people, and then we can we try to go there and find remains of whatever is coming
Yeah,
from the cosmos? Can we do that?
yeah, yeah, we can do that, but the meteorite which is going to fall must be fairly large, because most of the meteorites which you see in the dark sky or night sky, they have very short periods. The short period is from 2 seconds to roughly 6 to 7 seconds. So, one of the things which I strongly suggest, now we have made a camera to look for these meteorites using different parts of the sky, and for young students and amateurs, we also provide them charts, star charts, so they can actually plot the position from where it began and where the meteorite light ended. So from that, we are able to find the radiant. Radiant is most meteorites come from one particular point, which we call as a radiant. And these meteorites come in different colors. They can be yellow, they can be bluish white, they can be even orange in color. So depending on the elements that they have, they will show the colors. So you can even identify their possible elemental composition also, because they are burning, and their burning, they give you a characteristic curve or light, which can tell you whether it is aluminum or whether it is magnesium. All these elements can be identified. Now the next question which you asked is where they fall. Now the fall, what we see is at a distance. Now if we are able to track that and find if the fall was there, then we can actually go to the site, because today we have GPS positions for our site and where the meteorite is expected to fall. You get that point also, and from that you can find what could be the size of the meteor, but you got to go to that particular, and that positions can be picked up from the GPS of that region. And for our Odisha, we had to do the same exercise. We were seeing the event happened in Mulund, and we went to Odisha to track it down. So it is physically possible to look for them wherever it falls. You can pick that up. Have I
Sir,
answered it?
one
Yeah,
more question comes to mind that in our Himachal Pradesh, when we go
right.
to mountains and hills, we found many places of such kind of water ponds, big water ponds.
Hmm.
So, is there some special characteristic that it is made by some outer impact, or it is made geographically only on the Earth? Can be
Uh,
recognized in
yeah, it should be. It should be possible. If they are happening because of a meteorite which has fallen, we have a catalog for Haryana also, wherein we can look for crater formations in the earlier times, and also the one which you are telling me is of the ponds.
yeah.
Uh, we are aware that in that area also there have been meteorite falls, but it needs to be looked there. The crater formation, as I said, just 3-4 components of the crater formation is that does it have an uphill, does it have a rim, and
Okay.
the geometrical dimension.
Right.
So these are the basics, and I think for any person to do this is not very difficult. And then, depending on the diameter of the crater, you can also find what could have been the mass.
Fine, sir. Thank you very much.
Thank you.
Anyone else has a question?
Sir, I just wanted to know, uh, has there, when was the last meteor seen in India, fallen in India?
Last
Last year.
last year,
Last year.
2025. Yeah,
In which place, sir?
2025.
In
In which?
In
It
Maharashtra,
was
near
in
Sinnar,
Maharashtra, in a
Yes.
place called as Bid.
Bid.
Yeah, and it fell in three. The meteorite fell at three different points, but they were not very far off. They were in less than 100 meters. The three pieces which had fallen was one fell inside a hut, again making a hole through the steel roof, and then falling inside the house. One fell in the fields next door to that, and a third one which fell. There were a lot of plantations, so people would not allow to one to go and pick that up. So essentially, there were two bead in 2025. We have a friend in our group who is called as Rajiv. He has an all sky camera and he takes pictures of such fireballs and meteors. So it is not difficult now to do this kind of work. You can even use cameras with wide angle lenses and look for the sky. So you can actually now record these meteorites. This is one part of the talk that I have to tell you. The second part is even if you have an FM band radio or transistor, you can pick up the sound of a meteorite. And essentially, it's a whisper. So even if you have a 3-meter antenna and you can take the signal onto your FM radio, uh, you can actually pick up radio meteors also. But they make a hissing sound and you can discriminate from the background sound. So even now we are doing this kind of work for radio meteors also. And we encourage people to take up even in the departments and even in colleges. These can be live experiments for the students.
Okay, sir. Thank you so much.
Welcome.
Anyone else has a question? Okay, there is a question in the chat. How can we preserve the Lonar Crater? I mean, that's a live topic for you.
Yeah, I have been asked to monitor or communicate how to save the Lonar. One of the problems in Lonar itself is there is no much coordination between the archaeological departments and water resource and so what has happened is they have drilled holes of 600 feet not very far from the crater. Now that water also gets added to the lake. And to make the matters still bad, they have put fishes into that lake. And other wastewater is also pushed inside the Lonar. So these are few things which has happened in the last year. They say the rains were more strong, hence the water has happened. It's not only that the output from the sewage water is also led into the lake. Hence, one of the reasons we are trying to say that such activity should be kept away from the crater and not put all the wastewater into the lake. And the reason why we are trying to say this, because this is the only crater in the world. It's the third largest crater. And what is required is how to save this crater. I hope I have answered, and I would like more questions and more reporting on these because this is our national pride or even state pride. So I request all of our participants to take this message across to even those areas and tell them that we are actually not only making the lake worse from the international point of view, you are also spoiling our scientific work.
Definitely, Bharat, that's great thing. I mean, that's the initiative. I think what you are leading to save Lonar, and we are going to run the campaign for that the same. So We are
Yeah.
looking forward more to hear from you about what are the initiatives, what everybody would like to take. And I definitely think that you would help most of the organizations who are doing good work in astronomy, science, and all the things to take up this as an initiative where we need to save these precious locations, be it Lonar, be it Luna, or maybe any other location where these impact craters are there or scientific importance.
Right.
Thank you, Bharat sir. Over to you, Hemant sir.
Okay. Thank you very much, sir,
Yeah.
for
Thank you.
conducting this session. Now it's my duty to propose a vote of thanks for
Thank
our
you.
very respected Dr. Bharat Adur sir. So, Dr. Bharat Adur sir, distinguished members of NASNI, and all the participants present today with us, on behalf of NASNI, as a coordinator, it is my proud privilege to propose the vote of thanks for today's truly fascinating and enlightening talk delivered by our very loving Dr. Bharat Adur sir on meteors, meteorites, and impact craters. Sir, your vast experience in chasing, detecting, studying, and documenting meteorites and craters has given us a rare opportunity to witness the wonders of cosmos through the eyes of a passionate explorer and scientist like Dr. Adur. The images, observations, and personal experiences shared by you made the today's session exceptionally engaging, inspiring, and I think it is very educational for all of us. Your talk has ignited curiosity and excitement among astronomy enthusiasts, especially the younger generation with us, encouraging them to observe the night sky, understand meteorites scientifically, and appreciate these uh, precious signatures from the outer space we get. Such interactions are invaluable in promoting the scientific temper and astronomical awareness, which NASNI is doing for last 2 years. Now, the timing of this lecture is especially meaningful for all of us towards the forthcoming International Asteroid Day to be held on 30th of June, reminding us the importance of planetary science and public awareness about near Earth objects. So, we are deeply grateful to you, sir, for sharing your valuable time and sharing your immense knowledge and experiences with us so generously. Your enthusiasm and dedication have left a lasting impression on all of us, especially on this topic. I also extend sincere thanks to all NASNI members present today and participants who have joined today's session and contributed to making this program successful and interactive. And in the last, once again, heartfelt thanks to Dr. Adur and to everyone present here today. Thank you very much. Thank you all.
Thank you.
Thank you, everyone.
Thank you, sir. Now we are signing off. So, good night to all.
Thank you.
Thank you, everyone. Good night.
Good night, sir. Thank you.
Thank you, everyone. Bye.
Thank you, sir.